Hello guys, in this session we speak about using NumPy library for scientific computation. NumPy, which is abbreviation of numerical Python, is the essential package for scientific computation used for working with arrays. What's the array? An array is NumPy very fast than traditional Python lists. It also could be used for computing, for example, Pearson correlation coefficients and generate random numbers. Firstly, we have to install NumPy package if it is not installed. To install NumPy, we open Miniconda. Then we activate the environment which is we using. In our case, Conda activate DA35. Then we use pip install NumPy. Requirement already satisfied. NumPy already installed. To open Jupyter Notebook, we write Jupyter Notebook inside Miniconda, then enter. Now Jupyter Notebook is opened. Then we open NumPy file. We have to import NumPy library. We name it NP, import NumPy as NP. Let's create some array. For example, data equal np dot array. The numbers 3, 5, 7, 9, and 12. Let's check the type of data, DA. How we calculate maximum, minimum, and average. We can use the name of the array, da.max. The maximum is 12. In the same way, data.mean to find minimum. The minimum is 3. da.mean to find average. Average is 7.2. And to find sum, da.sum. Sum is 36. To find median, we have to use this function, np.median, then the name of the array, da. Median is 7. Create 1D one-dimension array, da equal np.array 1977. Then print da 1977. Then create another example, a equal np.array 2, 4, 2, 8 and 2, 3, 1 and 8, comma fluid type. Let's find correlation coefficient between these numbers. np.core_coef A. Correlation coefficient is 0.98. We can name it x and y. X equal np.array 2, 4, 2 and 8. Then y equal np.array 2, 3, 1 and 8. Now we find correlation coefficient between x and y by using np.corecoef correlation coefficient. Correlation coefficient between x and y is 0.98. We can name the result something. For example, we name it here r equal np.correlation coefficient x and y. Then we type r, which is 0.98. Now in our result we can find correlation coefficient between x and y. Now we select r. Our result is 0.98. We can also find Pearson correlation by using SciPy. We use import SciPy package.stats module. Then we use scipy.status.Pearson r between x and y. In this case, we have r, Pearson correlation, 0.98, and also we have p-value 0.01 to find the significance of this correlation between x and y. Another example, line space np dot line space 01 and 10. We have 10 numbers. We can create log space by using np.logspace 01 and 10. Also, we can use NumPy library for creating random numbers. At the beginning, from NumPy import random, then we use rn equal random.radiant 100. Then we print our result. Print rn. Rn is random is 45. Another example, da equal np.array 1, 2, 3, and 4. Then print the type of da, da.dtype. The data type is integer 32. Rn equal random.rand of number 3. Then print Rn. We have 0.88, 0.45, and 0.59. We can use NumPy for calculation. For example, da plus 1. It added 1 for each number. And also we can do multiply. For example, da multiplied by da. The result is 1, 4, 9, and 16. 1 multiplied by 1, 2 multiplied by 2, 4, 3 multiplied by 3, 9, and 4 multiplied by 4, 16. Let's arrange numbers by using NumPy. I equal numpy.arrange 20 dot reshape 4 by 5. A is 1, 2, 3, 4, 5 by 4 from 0 to 19. In case we have non-numbers, for example, we have x equal np.array 12, np.nan 31, 56, 88, and np.nan. To find sum of x, we use np.nan sum x, which is 187. To find mean, we use np.nan mean of x, which is 46.75. To find maximum, we use np.nan max of x, 88. In the same way, to find minimum, we use np.nan mean of x, which is 12. Now let's open this text file that includes average temperature of Munich from 1995 to 2013. The name of file, Munich temperatures average with bad data txt. We use np.load.txt with the path and we name it t. To find average of data of t temperature, we use np.mean t. We have 996. It means the data includes bad values. In the same way, np.mean minus 99, which is not possible. And for maximum, np.max of t 2013. Let's use combined condition. We name it keep equal t greater than minus 30 and t smaller than 50. Then we name our data t1 equal t with using combined condition of keep. Now our data should be greater than minus 30 and smaller than 50. Let's find maximum. np.max of t1 27.66. to find minimum and p.me in T1 8.9. To find minimum, the minimum is minus 16.77. That's the end of today's session.